Deputy Chief George Healy from the 13th Division, and I'm here with my counterpart from Con Edison, Tony Natale. We're here today to discuss Con Ed's energy storage system at 10651 98th Street in South Ozone Park. Tony?
So welcome to the Ozone Park Energy Storage Facility. Always a good idea if these are in your response areas to come out and visit these places on a, blue sky day. Low frequency, high hazard events. We don't get out to these often enough to become really good at them. So developing a pre-incident guide, making sure SIDs are in place, very, very important to our response tactics.
And good point, Tony. This is the Con Ed facility in New York City, but there are other private facilities around that we might not have the relationship with the owner of that facility as we do with Con Edison. So it's important that we develop those relationships so that when we do show up and maybe there is a problem with that system, we are better educated and we know not only who to talk to from that utility or that private entity that owns that, but we can interface with them and come together to an agreement of the best way to manage this incident.
So today what we're looking to achieve is taking you through some of the hazards and response tactics associated with any incident that could occur at an energy storage facility. So join us today as we walk through the facility and kind of point out those hazards and the appropriate response posture. And let's begin with staging, which is the most important thing we've learned after the incident in Arizona. Chief?
Well, absolutely. Some of you might be aware there was a very significant incident in Surprise, Arizona. The responding fire department units did take a no rush and cautious approach, all right? But they did not have that pre-incident planning and involvement with this utility out there. So they were really kind of figuring things out as that incident unfolded. And unfortunately, they were making informed decisions and they took some time and they did some things, and ultimately they found themselves in a situation where there was a significant event and several members were injured. And that's the best thing that we want to try to prevent here. So the main, I think, focus from the fire service perspective is going to be ensuring the safety of the community. As you can see, this facility is tucked right in between a public school with over 1,300 students. There's also a place of public assembly, which is a church and a bowling alley. So one of the primary things we're going to be looking to do when we get here, we're going to try to figure out exactly what's happening within this system. Is there a true failure and emergency? And then we're going to start with our life priorities, okay? This is an unmanned facility, okay? It's cordoned off, it's secure. We're going to make sure that we can protect the neighboring community and the exposures, and we're going to start to utilize some of the systems in place to benefit us. We're going to talk a little bit about a purge panel that we can purge the individual containers, and we're also going to talk about the fire department connection. There's a fire department connection on 98th Street. There's another one on 99th Street. One of the challenges you're going to have to overcome is the nearest hydrant would be down on 109 Ave as well as down on Rockaway. So establishing water supply, we're going to get into the manual dry system that's in this containers, but we're going to look to establish a water supply, and then we're going to wait for our Con Edison representative to come. We want to make sure we're talking to the right people from Con Ed, the people that have the knowledge about this technology and this system, and they're also going to be the ones that are going to be able to give us access to the facility.
Thanks, Chief. These are lithium-ion batteries. So in this facility, the two primary hazards are electrical safety and explosions. Explosions could come as a result of a battery failure. We've seen lithium-ion batteries fail, and when they fail, they have a tendency to produce a flammable gas. So when you produce a flammable gas in an enclosed space, you set the stage for an explosion. The difference between a fire and an explosion essentially is 4 walls, a floor, and a ceiling. So on arrival, it's important to understand if the facility has purge capabilities, it has deflagration venting, it has a way to safely discharge that pressure wave rather than what we saw in Arizona, where members opened the door and the gas came down through the upper explosive limit into the flammable range and basically caused an overpressurization, injuring that first due company. In addition, not only are there electrical hazards here, but they're DC. So I know a lot of members may carry pen detectors, AC detectors in their bunker gear. I know some of the SOC companies have these detection devices. They do not work with DC. All batteries, all green energy is DC driven. So those would be useless in this environment if we were looking to employ them to determine if something is actually energized or not. So we wouldn't be using those in this type of setting. So another key takeaway when it comes to Con Ed facilities, although the facades may vary, one important key note is at every entrance, you'll see a white hat sign. The white hat sign is basically to alert members that there is a high hazard on the other side that normally is not encountered by members of the department. These are a skill set that generally members don't possess, and they have to work closely with the utility to resolve any issues. So at the end of the day, when members go out the door, they're going out the door to save life and property. As the chief said, these are unmanned facilities, so there's no rush. This is going to be a slow type of hazmat incident. Planning and staging are probably the key things that we want to look at in the onset of the incident.
And we know by noticing that sign that that's where we're going to meet our Con Ed representative. The two white hats are going to show up, and this is where we're going to have our rallying point. The white hat of the chief officer, the white hat from Con Edison, which will be their subject matter expert on that facility. And this is where we're going to get together. We're going to start our exchange of information, and we're going to start to build out our plan to address this incident.
So on arrival, if it's observed that there is a white hat sign outside clearly indicating a Con Ed location, members are not to force entry. Very, very important takeaway. Do not force entry. High hazards on the other side of that fence line with no value added. One of the other things that we want to look at is, since the place is not normally staffed, there is always a number available to a 24/7 desk that can respond and provide an ETA for folks that will be responding to the incident at hand. And at this specific location, what members want to do on arrival or arrival to any energy storage system is look for a remote fire alarm control panel. That'll give you some pretty good insight to what's going on inside the facility without having to force entry. Chief?
One of the things, as Tony mentioned, was right here on the exterior, prior to Con Edison arriving, we do have a purge control panel. Again, we're not going to take any actions without direct communication from our white hat, letting us know exactly what information they have about this incident and what actions we should be taking, especially prior to their arrival.
So the way this system works, it's enabled with a 1620 key. We have the ability here to see if any of the clean agent, because this system is protected by clean agent, has discharged. Are there any supervisory or trouble alarms with the system? And it gives us the ability, once we determine which container is involved, we can actually purge the container of the clean agent and the flammable gas, which is key to ultimately making entry at some point.
It's also very important, Tony mentioned, and correct me if I'm wrong, but some of these facilities are built with a deflagration panel that would allow any sort of event to vent through the roof and potentially prevent any sort of unnecessary injury. But I don't believe that this facility has that in place, correct?
No, there is no deflagration venting at this facility. That could be identified by vents, as you said, coming through the roof of the container. This facility has purge system that works with a Class 1 Div 1 fan, fresh air intake in the back of the container, and discharge through the front. The front discharge is important because that's going to be a good barometer of what's going on inside. If we're purging, if we're seeing black smoke, obviously fire conditions, if we're seeing white smoke, that is actually a good indication that a module failed, and it's not white smoke, that's the flammable gas. It's going to present as white smoke.
We should also be getting our special hazmat resources to the scene. Of course, they can give you additional information. We are going to handle this as if it is a hazmat, But one of the additional challenges here is with that clean agent system, once that system discharges in one of these units, it's going to act to inert that space. And our standard meters, if they do not have an oxygen concentration, those meter readings cannot be confirmed as 100% accurate. So that's something that you're going to have direct communication with your hazmat crews, and they're certainly knowledgeable about their equipment and their meters. But once that space has been activated with that clean agent system and that space has been made inert, the oxygen has been displaced, that is going to be a challenge for us to take any sort of readings that we can have to let us know if we are anywhere near that flammable range.
Chief, let's take a look at the fire department connection on the side of the facility.
Sounds good. As I mentioned to you, one of the challenges for this particular facility is going to be our water supply. We do have a hydrant down on 109 Ave, but as you can see, we have the fire department connection here. This is a manual dry system, okay? The unit, if there is a problem, if there is a heat source, the heads, and we will show that to you here momentarily, the heads, like any other sprinkler head, will fuse, but it is a dry system, so there will not be any water flow until we show up. And we will have that conversation with the Con Ed representative when they think it would be appropriate for us to supply water to that container if there is a thermal runaway condition.
So recommended tactics on arrival, as you normally would, hit the hydrant, connect to the Siamese, but don't charge the line. So what we're looking for is we're not looking to charge the system until we make that decision jointly. Basically, once this is charged, it's going to pressurize every container. The only water flow we will get is if there's a broken head in the sprinkler above the fire area. So it's very important for the chauffeur to note if there's any water flow on the meters on the pump panel. So that's going to be a good indication of a fire condition inside the container. If there's no water flow, the fire is not that big.
As you can see, we are going to need a Con Ed representative here to gain access to the facility. And again, that's part of the safeties involved in this. There are some significant hazards at this facility. Of course, we can manage them, but we're going to want to make sure that we have that physical Con Ed presence here before we start to interact with these containers.
All right, so two of the things to note about this facility, it's under complete video surveillance. Anybody entering the facility, cameras around the facility so we have a good understanding of what's going on. And at our control center, we can view that. In addition, we also have the ability to see remotely the charging state of the batteries. And that's what we're going to talk about next, is the battery management system. That's going to give us good insight as to what's going on, the scope of the problem, how many batteries are affected. So that's going to be a very, very important piece of information. And on arrival, calling that number, they're going to have a really good sense of, has the fire system dumped, what's going on, has any equipment tripped offline, the state of equipment. So there's a number of things that they can see remotely. So, you know, it's advised on arrival to make that call. So folks, in this facility, there are 9 containers. There are 8 filled with battery modules, and there's 1 container that serves as the battery management system. Now, we're going to talk about points of isolation and shutting down the system. So what we're going to do is we're going to go inside the battery management container, and that is the primary point of entry that we want to make, because that's going to give us really good insight as to what's going on. So why don't we head this way?
And Tony, correct me if I'm wrong, but this is all being monitored remotely also.
That's correct,
So if
Chief.
we utilize that number at the front gate prior to the arrival of our white hat, they will be able to access this information and start to give us some of the intelligence that we need to potentially start getting a game plan to manage this incident?
That's correct. I think that's going to provide some initial insight that's going to give you an idea of how big the problem is. Because with our battery management system, as you're going to see, we can actually look at cell temperature. So clearly a good indication of how big the fire's grown to see how many cells and modules are affected. So why don't we come inside and start to talk about points of isolation when we have a problem. So strategically, the first thing that we're going to look to do is find out which battery set's affected. So what we can do here is, if we had a battery set affected here, meaning a container, we would hit the E-stop, and what that would do is that would shut down that battery. Now, it doesn't discharge electricity, it just stops the charging and discharging, okay? So now it doesn't remove that stored energy, and that's the biggest problem that we have with these battery systems is that retained energy still will present a hazard to the members. The second part that we would engage in is, after we shut it down, we would turn this handle, and this provides a physical break in the conductors. This is a disconnect switch. Now, we generally want to isolate just the affected portions of the facility. If the facility is running, it's probably running at a critical period where we need that additional power. So that's why it's very important there is a full E-stop. We call these E-stops that will shut down the entire facility, and it's right behind you. Shutting that down has to be a joint decision between our white hat and the chief officer on scene, because the issue with shutting down the entire facility could destabilize the network that this facility is supplying. So we don't want to trade off problems here for more problems out in the network. So it has to be a calculated decision, and generally what we try to do is just isolate the containers that are affected rather than the entire facility.
Let's just re-emphasize one very important point that Tony brings up. This can isolate this battery system from the network, but those batteries are not de-energized. And if you look at some of these events that have occurred with lithium-ion battery technology, there might be an incident. These batteries can go into what we call thermal runaway, and they can either go into a more normal state, whether that be after fire department interaction, or maybe a particular cell that was in thermal runaway starts to kind of calm down and relax and go back towards a steady state. But there have been some pretty notable incidents where the system appears to be back to normal. Everything seems to be functioning properly. We do know that we have a problem with a particular cell, but hours later, there can be another secondary event where more batteries start to fail. It starts to cascade. So as we mentioned, it is, one, a no-rush approach, but two, by shutting this system down at the battery management system, we still have considerable stored energy, and that stored energy can potentially become a problem again, even hours later.
Modules are connected by strings. There's 35 modules in a string. So it's important to get into the battery management system, because that's going to give us good insight as to what's going on with the system without having to put members in harm's way. So we would be able to look at the container in question, and this is representative of each of the modules in there. It tells us the state of charge, which clearly is 93%. And then what we can do is we can look at each one of the modules. So as we click that, we can look at the temperature, and that would be a good indication of how many are involved and how many are on fire, or at least affected by the fire, because that's the other issue. Modules that are impacted by heat will fail and discharge flammable gas. And that's why it's very important to purge the flammable gas from the container before considering making entry. So on arrival, one of the first things we want to do is we want to review the fire alarm control panel to get a sense of what's going on. Are there any alarms up? The second thing we want to do is we want to get into the battery management container and kind of determine where the problems are. Then we want to look to conduct isolation. Now, the first method of isolation is local to the container, but if the container is compromised, obviously we can't shut the container down from within inside, so we can back up to the battery management container and shut it down from here. The way this facility works, we can depress the red E-stop and then turn the disconnect, and that will isolate the containers in question. Each facility by law is required to have an E-stop that'll shut down the entire facility, and that is located right there.
So Tony, just to take a step back, we have this capability once we're on site, but are there procedures in place, and do you have the capability, that remote monitoring station, if they do see in fact that there is some sort of issue occurring, maybe that the clean agent has discharged, there is smoke alarm activation, do they have the ability, based on the intelligence that they're receiving, to maybe start this process before even our arrival?
Absolutely, Chief, and I think that's why it's important to give a call to the number on that sign. They would be able to determine what's going on inside, how many containers are affected, how many modules within the containers are affected, if the system has dumped, and more importantly, they can do isolation remotely. So they'd be able to isolate the containers. They can actually even isolate the power coming into the facility. So there's a lot of steps that can be taken prior to the arrival of Con Ed personnel. So it's very important, actually quite vital, that that call is made, and it gives the chief officer on scene a lot of intel to operate with, knowing what's going on without having to open a container up or force entry.
And that's part of the importance of us having this relationship. That number is also in CIDS, our critical information dispatch system. So if the address is transmitted to the dispatcher, that CIDS information will show up on our response ticket, and it gives our incident commander, who will be responding, that additional information and ability to start gaining situational awareness and making that phone call while they're responding in the vehicle.
That's correct, Chief. These are low frequency, high hazard locations. Members don't come to these sites often enough to sharpen their skill sets. So it's very important that we work closely together to identify what the hazards are and develop the appropriate response tactics. Chief, would you like to see one of the battery containers?
That would be great. And again, just for our FD units, this is a familiarization. We're not showing you this stuff to try to give you the ability or the knowledge to operate without our partners from Con Edison. We want you to know what this facility is. We want you to know what it looks like. We want you to know the hazards of this facility and certainly its capabilities. But again, it's paramount to understand we take these actions based on our discussions and collaboration with our Con Ed partners.
Thanks, Chief. Come on. Nfpa 855 is basically the guidance on the installation and storage of battery systems. So basically what they do is, in that standard, along with the fire code, requires certain signage on the doors to alert you as to the hazards that are on the other side. One of the primary ones is gas fire extinguishing system. So this suggests that there's a clean agent system that is protecting this facility. In this case, this happens to be FM200. One of the other commonly used ones is Novak. These are the replacements for Halon. So again, clean agent system, not to leave any debris material, such as if we use Purple K or something else.
But again, that's important for our responders to know and understand, because if that system has activated, and at some point, if there is a decision jointly with our Con Ed representative to maybe make entry into this container, we have to realize that that space has been inerted by that activation of that clean agent. So we're going to have full SCBA and make entry under strict guidance and supervision.
I can assure you, if there is a condition going on inside, it's time to don your SCBA, because there's nothing in there that you want to be breathing in. So let's take a look inside. Before we do that, a good indication from the street that you can see, and you can correlate it to the containers, is this is the audio and visual alarms that are associated with the container. You'll find that on the outside. This is part of the fire code. They must be on the outside to alert members where the problem is. So in addition to reviewing the fire alarm control panel, you will see the audio and the visual alarms on the outside. Now, what'll generally happen is you'll see a strobe if the system is in alarm mode. If you actually have a fire, you'll get the audio and visual, and within 90 seconds, the clean agent will dump. All right, so this is the clean agent system. This is FM200 piped in overhead, and the red piping with the large orifices are basically an indication of a clean agent system. It's a very, very heavy gas. If the door was left open, the gas would roll out the door almost like a liquid would. So it's very important when these systems are discharged, the container needs to be airtight, so both doors need to be closed, or the system wouldn't work effectively. Right now, what you're looking at in the corner is you're looking at the internal audio visual, the control panel. This, if we depress that button, that would actually interrupt the discharge of the gas. So if there's something going on in the container and it was about to dump, this would go into alarm mode. This would allow us to delay that as long as we held in that button. Each clean agent system has a manual dump station. So by pulling this, this was discharge the system. Now, as these containers are unattended, they are equipped with smoke and heat detectors. So basically what would happen is if there was just a smoke condition, you would get a flashing light on the outside to let you know there's a problem. For the system to actually dump, we need cross detection. So we need two sensors to go off at once. Either a smoke and heat, two smokes, two heats, and that would cause the system to dump. What you're seeing overhead down the long axis of the container is the water-based fire protection system. When the Siamese is charged outside, this pipe is pressurized and water will only discharge if the bulb in the head is broken, and that's broken by the presence of heat.
Tony, if we could just go back for a moment to our clean agent system. My understanding, and if maybe you could kind of educate our viewers, that system mostly would be efficient at extinguishing the wire harness if it was burning. If we did physically have thermal runaway occurring within one of the battery components, is that effective at extinguishing that?
Basically, the clean agent systems aren't rated. They're not listed for these types of fires. True, Chief, the system was installed for ancillary fires, control cable, Class A hazards and other things like that. Basically, what that does is it will flood the room, but it's not going to manage thermal runaway. This is a chemical condition that's going to play itself out, and the best thing that we can do is start to de-energize equipment around it and basically control the hazard that way. But the system generally will have no effect on extinguishing a battery that's in thermal runaway.
And that's good information for our first responders, right? I wouldn't want anyone to be lured into a false sense of security saying, well, we have this clean agent system, it's in place, it's activated. Maybe we're looking at the outside of our container with a thermal imaging camera, not showing any significant indication of heat, but that system's ability to deal with battery failure is extremely limited. And as we're going to just mention time and time again, these events will be, a long duration event, and the hallmark to our safety is going to be slow, deliberate decision making and taking action when necessary, but in consultation with the other first responders and our partners from Con Edison or whatever utility is potentially dealing with that particular installation.
That's correct, Chief. Thank you so much. So what works and what doesn't when it comes to suppression? So Purple K has a Class C rating, which means it's rated to 100,000 volts. It's safe to use. However, it would probably have very little effect on the chemical reaction that's going on during thermal runaway. Carbon dioxide, also Class C rating, 100,000 volts. But unfortunately, for that to be effective, we would have to put you inside the container. And that's something that we're not looking to do, especially if we're not sure of the scope of impact right away, with a large scale fire. The other thing that we want to look at is copious amounts of water. Again, energized source, how do we actually engage in that? So what we look for is at least a 25-foot standoff distance for a solid stream. If we're going to open that stream up, so that's how we manage leakage back to the nozzle person, is basically if we have a tight stream, we need to compensate with distance. So the theory is, if I want to be up close and personal, I open the stream, and if I want to tighten that stream, I just have to back away. So we could put members on the platform fighting the fire. We would just look to open the stream up to manage that leakage. So that's probably the most key element in responding to electrical fires, is to manage the current that could potentially come back through the stream. So tight stream, 25 feet. Once we open that pattern up to about a 30-degree fog, we can get up close and personal, and purging in the doorway would be most adequate to do that.
Again, as we respond, we're going to want to use that information in SIDS to contact Con Edison, find out what information they have about the source of the alarm. This is going to be a no-rush approach. We're going to use those standoff distances, stay out of this facility until our white hat makes contact with us. We're going to, again, use our resources. We can utilize our thermal imaging camera. We should have our hazmat resources responding. We are going to be prepared to use water if directed to by Con Ed through that pre-piped fire suppression system. And then we're going to take our time to manage this incident appropriately. This incident is going to take a lot of resources and a lot of time to make sure it's safely and properly managed and mitigated. We're going to take our time, we're going to talk to Con Edison, and we're going to make educated decisions to make sure we safely and efficiently extinguish this fire.
So as a reminder, when companies are out doing building inspections, they want to look for these locations within their response area. Clearly, facilities that need a pre-incident guide. One of the biggest issues with the response to Arizona, the Surprise Arizona event, was the members saw that facility for the first time on game day. You really need to get out here on a blue sky day, take a look around, develop the SIDS pre-incident guide, because game day is not the time to learn. Hazards are too high and the stakes are even higher. Great risk for personal injury if you're not prepared. So waiting for the white hat to show up, and again, as a reminder, the only person you're taking tactical direction from is somebody wearing a white hard hat. That's the person in charge for Con Ed, and they are responsible for your safety. Chief.
And we have to know who those players are prior to that incident. So this is the Con Ed facility that's in New York. There are other facilities that are private. So if you haven't made those contacts yet, please do, so you can ensure that when the time is needed, you can talk to the right person and make that educated decision.
Thanks, Chief. I hope this worked out.
Thank you, Tony. Greatly appreciated.